I just dropped something on the floor. Hey, Algebra 1, it's Mr. Canfield. So I had a request to do some explanation of our homework, so I'm going to go through that, and hopefully this will help you. So I'm just going to go down and I'll do the odds and kind of go until, yeah, okay, so I might even hit the back for you. So it shouldn't be too long though. It's not a whole lot for us to unpack here. So I see qp cubed r to the 0 times 2p cubed r to the 0. So anytime we see something to the 0 power, we can treat that as times 1. This is just 1. It's not r to the 1, it's 1. So it's like qp cubed times 1. And if we're multiplying by 1, it doesn't matter. It doesn't change anything. So that means that I can essentially ignore that they're even there. Let's see, there are no other q's, so I'm just going to have to write the q as I see it. There's just a single q. There are p, let's see, we have 1, 2, 3, 4, 5, 6. We have 6 p's, and I have a 2 out front. So let's see, what's the next one look like? The next one I see x to the 4th, z to the 3rd times 3z x squared y squared. So I have x's, I have y's, and I have z's. I have a 1 out front and a 3. So 1 times 3 is 3. And then we can just add the exponents together. So I have 4 and I have 2 x's. So maybe I should explain this. Let me just kind of break this down. This is saying I have x, 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 z, z, z times 3 times z times x times x. Boop, 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 boop. Okay. Times y. And all we're doing is we're going, okay, well, how many x's total do I have? Well, 1, 2, 3, 4, 5, 6, right? 4 plus 2 is 6. How many z's do I have total? 1, 2, 3, 4. And I'm going to write this in alphabetical order. You don't have to, but it's good practice to write them in alphabetical order. I've got y squared. So there we go. Let's see. Let me see if any of these get more complicated. Well, may as well just do 5 since we're here. So I've got 4p cubed. So without writing all this out, I know that I'm going to write p 3 times, just like I wrote x 4 times here. So I'm going to write p 3 times. How many times do I write over here? Once. That's a total of 4 times. How many times do we write q? 4 here, only 0 times here. Remember, this is effectively 1, it's gone. 4 plus 0 is 4, so I can say this is p to the 4th, q to the 4th, and r to the 0 plus 3 is 3. Now, if I'm looking through, I see a 4 and a 1, so 4 times 1 is 4, and there we go. Look at number 7. So remember, when we have parentheses and something outside of the parentheses, we can apply this 3 to the exponents inside. So I can say this is 2 to the 3rd times q to the 9th. So we can multiply each of these exponents by that exponent outside, so we'll apply that. If you'd rather write 2 to the 3rd and find out what number that is, 2 times 2 times 2, and get 8, that's also okay. So 8q to the 9th. Let's look at number 9. We have a 4 outside. So let's just talk about this really quick. The idea here is that it's this thing, 1, 2, 3, 4, 4 times. So I can write this as like j squared k to the 4th, j squared k to the 4th. Ugh, j squared k to the 4th. Okay, but if we do that 4 times, we can see that we have j 1, 2, 3, 4, 5, 6. We have 8 times we have j, or just 4 times 2. So j to the 8th. That's why this property happens. Then here I have 4k's, 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 4k's. It'd be nice to have 4 4k TVs, but I don't. That's too many. All right, so anyway, we have 4, 4, 4, 4. So 4 times 4 is 16, so we have 16 Ks. All right, so let's move on. So on number 11, these are the ones that I like to write out, even though we don't need to, but I've got x and then y and then y and then z and then z and then z. down here, I've got a 2, and then x, and then x, and then y, 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 and then if we were in another country, instead of saying z, we might say z. Z, 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 Z. And now we just go and say, okay, do we have anything that cancels? Anything that when we divide it, we get 1, because x divided by x is 1. So 1, and then 1. And so I love doing these on my paper because I just get to cross all this stuff out. Let's see, z, z, z. Notice we can only cross, things that actually cancel out with each other. An x and a z wouldn't cancel each other out. Remember, the reason they cancel is because they equal 1. So, there's nothing left on top. But remember, all these x's and z's and y's that are canceling, they're turning into 1s. So we really have 1 times 1 times 1 times 1 times, we have a bunch of 1s on top, which is just 1. And on the bottom, we have a 2, a y, and a z. So that's the long way to do this. The short way to do this is I like to draw my fraction bar. Let's see, I look at the numbers out front and I see a blank and a 2, so I know it's a 1 and a 2. So I'll write 1 over 2. Then I look at my x's and I subtract those exponents. So 2 minus 2 is 0. We're left with x to the 0 power, which means it's gone. Then y to the 2 and y to the 3. Oh, where's the bigger amount of y's left over? It's in the bottom. So I know that if I were to write it out and cancel, then I would have 3 minus 2. I'd have 1 left over. And then look at my z's. I've got more on the bottom, so 4 minus 3. I'd have 1 left down here. So that's the way I'm going to do the next one. I'm just going to look at it. I'm not going to write it out. And I'm just going to think through this. So I've got a 2 on the top. I've got 3 on the top and 2 on the bottom. So that's going to cancel out 2, and we're going to have 1 left over on top. So why do the zeros playing with me? They don't exist. All right, there's still 1. So I've got 4 y's left over on the bottom. Oh, and there are no z's to play with either, so the z just chills. And then number 15, we've got x to the 4th, x to the 3rd, so we'll have a single x left over up here. Y squared, z squared, because there's nothing to play with them. And the 4 comes down where it was. So, hope this little video was helpful going through these. Let's see, is there anything over here? I think I'll look at 8 and I'll look at 16. And I think that should cover a majority of issues that people run into. So number 8, if I look at number 8, a common thing that people will do is they'll see the 3 out there, so they'll write 4y x to the 9, right? Because we do 3 times 3 and 3 times 4. We're applying it to each of the exponents inside. So x to the 9, z to the 12. And this is a very common thing that people will do, and it's a very common mistake. Because remember, the 4 has an exponent of 1, and so does the y. Remember, if there's no exponent, it's implied that it's 1. So the 3 actually applies to the 1 and the other one too. So this actually is 4 to the 3 and y to the 3, x to the 9, z to the 12. So now I would leave that there, or if you really care, 4 cubed is 64, so I could write 64, and I'll write it in alphabetical order too. X to the 9, y to the 3, z to the 12. So make it fancy. All right, last one I'm going to look at today in this video for you. So if I look at this example, it says 2m cubed p to the 4th times m times n squared times p squared all over. Blah. So there's a lot of ways to unpack this and start breaking it down. I'm going to do what I think is going to be simplest for a lot of people. And that way is kind of simplifying what we see. Like I can simplify this chunk. So I have a 2 and I don't have anything, so it's a 2. M to the, let's see, I have 3 here and I have 1 here. That's m to the 4th then. And then I see an n. I see an n squared, so I'll write an n squared. And then p to the 4, 5, 6, p to the 6. And then I'll look at the bottom. Oh, I have something in parentheses in the bottom, so I can apply this exponent to each of those exponents and get m to the 6, right? Because 2 times 3 is 6, and then 3 times 3 is 9. So m to the 6, n to the ninth and p to the ninth. So now that I've kind of cleaned up the top and the bottom, now I can do it like it's a normal problem from earlier and go, okay, well, I have 4 m's and 6 m's. Oh, so 4 of them are going to cancel. Oh, let me look at the 2 first. Sorry, there's a 2 and there's no number, so I just leave it as 2 over 1. So back to the m's. 6 of them, 4 of them. Cancel, everything's canceling out. There are going to be 2 left over downstairs. So I can write 1m squared here, n to the second and n to the ninth. So 2 of them are going to cross out, and we're going to be left with 7 on the bottom. And then this last one, we have 6 here, we have 9 here. And so 6 of them are going to cross out. We'll have 3 left over on the bottom. I should say denominator. We have 3 left in the denominator. So, okay. I hope this was helpful, and feel free to send me an email or whatever if you're struggling getting through any more of this. But yeah, so the ones in the back, like 24, I did leave these as bonus problems to you. Again, they look really bad, but if you just kind of clean up the top, clean up the bottom, kind of work through things, as long as you kind of do each rule when they happen, we'll get there. So fine, you talked me into it. I'm going to go through and do what I think is probably the hardest question on here. It's a huge thing in parentheses with a 3 on the outside, and lots of stuff happening on the inside. So if we're careful and take our time, this really isn't that bad. So I'm going to focus on the top first, and I see I have a p to the 1. Do I have any other p's on the top? P to the 1, p to the 2, p to the 1. Oh, so 1, 2, 3, 4. I have p to the 4th. I should have actually focused on the coefficients first. I had a 1, I had a 2, and I had a 1. 1 times 2 times 1 is 2, so I'll have a 2 out front. Okay. So I did my coefficients. I did my first letter in the alphabet. Second letter in the alphabet is Q. So I have Q to the second. Do I have any other Q's? Oh, here's one. Q to the 0. Oh, so it's not there. And then a Q to the 1. So I have 2 plus 0 plus 1 is 3. So Q to the 3. And then I've got R to the 0, which is 1, so it's gone. R squared and R to the 4th. So we have 6 of those. 2 plus 4 is 6. And then on the bottom, I've got something in parentheses. Hey, this Q to the 0, we'll talk about that in a second. All right. So 2 times 1, we get R to the 2. Then 2 times 4, we get p to the 8th. Now, this is q to the 0. What's 2 times 0 get us? It's still 0, so it's still q to the 0. It's still 1. I still don't need to write it. So I have the option now. I can either try to clean up the inside, or I can apply the 3 to every single exponent on the inside. Everybody's a little bit different. Some people prefer to apply the exponent first. Some people prefer to simplify the inside first. They both work. I'm going to simplify the inside first. So I see I have 4 p's here and 8 p's here. That means that there's only going to be 4 p's left down here. The 2 has no friends, so it's just chilling. Q has no friends, so it's just chilling. And R, there are 6 of them and there are 2 of them. So that's going to mean that there are 4 left on the top. And then finally, we'll take the 3 and we'll apply it to all the exponents. But remember, 2 actually does have an exponent. And so it turns into 2 to the 3. Q to the 3 times 3 is 9. R to the 4 times 3, which is 12. And then so that'll be P to the 12 as well. And so that monstrosity boils down to this smaller monstrosity. Okay. Now I think I'm done. Bye.